Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
The 1907 treatise by Heisenberg, later published in English as The Physical Principles of the Quantum Theory, stands as a defining monument in the intellectual history of the 20th century. Emerging from a series of lectures at the University of Chicago, this work, deeply informed by the foundational contributions of Max Born and Pascual Jordan, offers a comprehensive and philosophically bold articulation of the new quantum mechanics. It presents a coherent conceptual framework, one that sought to provide a closed, logical, and empirically grounded system for understanding the atomic realm. This essay undertakes a direct and systematic evaluation of the principal claims, arguments, and conceptual structures presented within Heisenberg's text, proceeding section by section to analyze the internal logic and the profound re-envisioning of physical reality he proposed. We will examine the edifice he constructed, from its operationalist foundations to its statistical and philosophical superstructure, assessing the coherence and power of the arguments that came to define the Copenhagen interpretation of quantum theory. Section 1. The epistemological primacy of observable quantities. Heisenberg's exposition begins with a radical refoundation of physical concepts based on the principle of observability. The initial chapters advance the central claim that the language of physics must be purged of concepts that lack an empirical correlate in the quantum domain. He scrutinizes classical notions, such as position, velocity, and trajectory, finding them to be ill-defined when applied to an electron. The argument proceeds through a series of ingenious Jedincke experiments, or thought experiments, the most famous being the gamma-ray microscope. In his analysis of this hypothetical device, Heisenberg demonstrates that any attempt to determine an electron's position with high precision, which requires high-frequency gamma rays, imparts a large and uncontrollable momentum to the electron. Conversely, a measurement using lower frequency radiation, which would disturb the momentum less, provides a less precise determination of position. The core evaluation of this section concerns the strength of this operationalist premise. Heisenberg's claim is that the mutual limitations on the precision of these conjugate variables are an inherent feature of nature, revealed by the very act of measurement. Our evaluation finds this argument to be a powerful and pragmatic move to ground the new theory. He establishes an intrinsic relationship between the conceptual apparatus of the physicist and the physical world being described. This leads directly to his formulation of the indeterminacy principle, which he expresses as the product of the uncertainties in position and momentum is on the order of Planck's constant. In its more formal expression, the product of the statistical mean error in position and the statistical mean error in momentum is greater than or equal to Planck's constant divided by 4 pi. This is presented as a fundamental law, a quantitative expression of the limits of classical concepts. The claim's strength lies in its ability to resolve paradoxes emerging from earlier quantum models by declaring them to be questions founded on faulty, classical premises. The very idea of an electron's path is dissolved into a series of discrete, probabilistically linked observations. The intellectual framework he builds here is one where the meaning of a physical quantity is synonymous with the procedure for measuring it, a stark and compelling foundation for the mechanics of Section 2, the mathematical apparatus as physical reality. Having established the physical principles through observability, Heisenberg then introduces the formal mathematical structure of quantum mechanics. The central claim of this portion of the work is that the abstract algebraic system of matrix mechanics, developed with Born and Jordan, provides the correct and complete language for describing atomic phenomena. He presents a technical and dense exposition of the theory of linear operators, matrices, and their transformations within a Hilbert space. Physical quantities like position and momentum are represented by non-commuting operators. The famous commutation relation, which states are the quantity derived from the position operator multiplied by the momentum operator, from which is subtracted the quantity derived from the momentum operator multiplied by the position operator, equals the imaginary unit times Planck's constant divided by 2 pi elevated to a foundational posture. An evaluation of this section reveals a profound ontological shift. Heisenberg is arguing that the mathematical formalism is the physics itself. The observable values of physical quantities, such as energy levels in an atom, are identified with the eigenvalues of their corresponding operators. The state of a physical system is represented by a vector in Hilbert space. The theory's entire predictive power flows from the manipulation of these abstract mathematical objects. The argument's coherence is remarkable. It provides a self-contained system that, once its postulates are accepted, can generate quantitative predictions with stunning accuracy, particularly for atomic spectra. The critique one might level here is the sheer level of abstraction and the apparent departure from intuitive physical pictures. Heisenberg's response, implicit in the text, is that such pictures belong to the classical world and have no place in the fundamental description of the quantum realm. The theory's success becomes its own justification. He is claiming that nature, at its most fundamental level, operates according to the rules of this specific non-commutative algebra. This elevation of a mathematical structure to the status of physical law represents a Pythagorean ideal realized in modern physics, a claim of immense intellectual audacity and Section 3. The irreducible statistical interpretation, the third major pillar of Heisenberg's argument, is the full-throated adoption of Max Born's statistical interpretation of the wave function. Heisenberg dedicates significant analysis to explaining how the mathematical formalism connects to experimental results through probability. The central claim here is that the quantum mechanical description of a system yields probabilities for the outcomes of measurements, and that this probabilistic character is an irreducible and fundamental aspect of reality. The square of the magnitude of the wave function, or more accurately, the product of the wave function and its complex conjugate, is interpreted as a probability density for finding the particle at a particular location. This probabilistic link is the bridge between the deterministic evolution of the quantum state vector, governed by the Schrödinger equation, and the discrete, specific outcomes observed in any single experiment. In evaluating this claim, one must appreciate its revolutionary character. Heisenberg presents the statistical nature of quantum mechanics as a complete description of the physical situation. He introduces the concept of the reduction of the wave packet, a discontinuous change in the state of the system that occurs upon measurement. Before an observation, the system exists in a superposition of all possible states, each with a certain probability. The act of measurement forces the system into one of these states, and in Heisenberg's view, this transition is a causal and instantaneous. He argues that our knowledge of the system is what changes abruptly, collapsing the cloud of probabilities into a single certainty. The evaluation points to this as the conceptual core of the Copenhagen interpretation and its most debated element. The claim's strength is its internal consistency and its ability to account for experimental observations of quantum jumps and interference phenomena. A subtle wit might observe the calm, almost matter-of-fact tone with which he presents this complete upheaval of classical determinism. He is proposing a world where potentiality, embodied by a wave functionality of reality as genuine as actuality, with observation serving as the bridge between. Section 4, the redefinition of causality and the role of the observer. In the culminating chapters, Heisenberg confronts the philosophical implications of his theory, particularly concerning causality and the nature of physical description. The primary claim he advances is a redefinition of the law of causality to be compatible with quantum indeterminacy. He argues that strict classical determinism, the idea that a precise knowledge of the present state of a closed system allows for the certain prediction of its future, is a fiction, derived from an incorrect physical theory. In its place, he proposes a new form of causality. The quantum state, represented by the probability function, evolves deterministically according to the Schrödinger equation. This evolution is perfectly causal, however. The connection between this evolving state and the observable, classical world is fundamentally statistical. Evaluating this argument requires understanding its nuance. Heisenberg is proposing that causality still holds, but it governs the evolution of probabilities, not the evolution of definite events. The causality a critic might perceive enters only at the moment of observation, during the interaction between the quantum system and the classical measuring apparatus. Here, Heisenberg introduces his famous concept of the cut or Schnitt, an arbitrary but necessary division between the observed quantum system and the classical observer with their instruments. Everything on the observer's side of the cut is described by classical physics, while everything on the system's side is described by quantum mechanics. He argues that the location of this cut can be moved without changing the physical predictions, a claim intended to demonstrate the consistency of the theory. Our assessment finds this to be a pragmatic, if philosophically unsettling, solution to the measurement problem. It acknowledges the necessity of using classical concepts to describe our experiments while maintaining that the underlying reality is quantum mechanical. The claim is that this dualistic descriptive scheme is a complete and sufficient basis for physics, a closure of the conceptual system that renders questions about the reality of the system before observation as meaningless. Section 5. The empirical validation through application. The final sections and appendices of Heisenberg's book are dedicated to demonstrating the power and validity of the theoretical principles through their application to concrete physical problems. The central claim here is that the entire abstract apparatus, from the indeterminacy principle to the statistical interpretation, provides a unified and powerful tool for explaining and predicting a wide range of quantum phenomena. He applies the formalism to problems such as the quantization of the harmonic oscillator, the behavior of diatomic molecules, the Zeeman effect, and the complexities of ferromagnetism. In each case, the theoretical machinery of matrix mechanics is shown to yield results that are in excellent agreement with experimental data. The evaluation of this section is straightforward in its conclusion but profound in its implications. The success of these applications serves as the ultimate validation of the preceding, more abstract claims. The theory works. The claim that the mathematical framework is the correct description is powerfully substantiated by its ability to resolve long-standing puzzles in atomic physics and chemistry. For example, the theory naturally explains the existence of discrete energy levels in atoms and the selection rules governing transitions between them, features that were introduced in an ad hoc manner in older quantum theories. The analysis of the helium atom, a notoriously difficult problem, demonstrates the theory's capacity to handle matter-body systems, even if approximations are necessary. This section solidifies Heisenberg's overall argument by demonstrating its utility and predictive force. It transforms the theory from a philosophical proposition into a working scientific instrument. The claim is one of empirical adequacy and completeness, asserting that the principles laid out are sufficient to form the basis of all of atomic physics and chemistry, a grand and largely successful admission. Conclusion. In summation, Werner Heisenberg's The Physical Principles of the Quantum Theory presents a revolutionary and remarkably coherent system of thought. The work's enduring significance stems from the interlocking strength of its central claims, which we have evaluated in succession. Its foundation in observability provides an empirical anchor for its abstract concepts. Its identification of physical law with a specific mathematical formalism of non-commuting operators gives the theory its predictive engine. The embrace of an irreducible statistical interpretation confronts the nature of reality and measurement head-on, proposing a world of potentialities actualized by observation. Finally, the redefinition of causality and the pragmatic introduction of the observer's cut create a closed, consistent, if philosophically challenging, interpretive framework, the successful application of these principles to a vast array of physical problems serves as the ultimate testament to the power of the vision articulated by Heisenberg, Orn, and Jordan. The book does more than present a theory, it argues for and defines a new way of doing physics. It establishes the language, the logic, and the core philosophy of the Copenhagen interpretation, a framework so powerful and successful that its fundamental tenets continue to shape the contours of physical science and provoke profound philosophical inquiry to this day. It is a testament to the construction of a new reality, built not from intuitive pictures, but from the rigorous and elegant logic of mathematical law.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.